Hi. So we'll get some inspiration from finance, but we'll try to spend most of our time in the recommender system world. There's a lot of theory in optimal portfolio management. Suffice to say, I think most corners will you will find people optimizing something called the Sharpe ratio, which is a proxy for reward by risk. A very nice exposition of this is in Dr. Steele at Wharton's his resource here on Kelly Bryman and how much should I bet. The and it references the original papers by Kelly in 1956, Bryman et al. 1961. There are some other nice expositions also on the internet. But suffice to say, the general idea is instead of designing your portfolio to maximize for reward within your constraints, like the amount of money you can invest, etc. You can optimize for reward by risk, because risk is what you're limited by. There's a nice word I saw in one of these papers, which was about one of these articles, which was about minimizing the risk of ruin. This will go. This matches very well with what we will eventually say, that hey, in the recommender system, users can consume, but they can also exit. And when they exit, your so-called repeated game of showing a recommendation and seeing the value that the user gets, if they exit the game, then you don't get any further chances, right? That's in the context of portfolio management. That is sort of like stopping to invest. And um, in this case, that users will do that only when the money becomes zero, and hence the parlance of risk of ruin. But there's a lot of theory here you should look at. The general summary of it is, in finance, the conventional wisdom is to invest based on expected reward divided by expected risk. There's a collab in this context that I've drawn up. What it does is it looks at two ways of investing in stocks, and it compares the returns. And at the end, you will see it shows that investing in a risk-aware manner, basically reward by risk, leads to a better outcome. And does that, I'm giving you only, again, this is not advice on portfolio management, and you know, your situation is your own, and optimize for that and all those nice just disclaimers. But let me just walk you through the general idea. We're taking stock returns. We're taking VIX, which is a measure of stock market risk, just to see the data. The close prices is what we care about. We'll merge them. Again, this just makes sure that the close X is SPY and close Y is VIX. Then we are going to mock an inverse risk allocation. We'll take the average value of VIX over the entire period, and on every day, the average value divided by that day is the one by risk formulation. We are going to eventually take a 3-day rolling window of it, and this is just so that this is slightly transaction efficient. You don't have, I'm just trying to be a little more realistic in this. The returns of holding SPY that day are this, merge close extra percentage change, and the one of the portfolios that we will compare is just that cumulative SPY returns, which is what we calculated here. And the other portfolio we will calculate is a risk-aware portfolio return, which is the returns of SPY that day multiplied by a scaling factor. And the scaling factor, when we more than one or less than one, in fact, here in this cell, we make sure that the average value of the scaling factor is exactly 1. Why? We take the average here. We take the average here, and then we divide it by the average. So this makes sure that the resulting value of the average value of this scale is exactly 1. And so we are comparing two portfolio management systems which have the same scale. The only difference is one of them invests 100% in SPY. The other one invests in a manner that is 1 by VIX. In other words, 1 by risk. And you can see that the risk-aware manner is higher, 1.81 to be exact.